Hey, let's start with number one. Number one says state the quadrant where the terminal side lies. Terminal side means where the angle ends. Drawing our coordinate plane and going negatively, we always start on the x-axis right here. Going negative means going in the reverse direction, backwards. One quadrant is negative 90. Doing another quadrant is a negative 180. So we're over here now. And then if I did another quadrant, I'd be at negative 270, but that's too much. I have to go from negative 180, I have to go another 41 degrees, which is like right here. And then there would be my end side, my terminal side of that angle. So it's in quadrant 2. Let's do number 2. Let's find where negative 7 pi over 3 is. Again, we start on the x-axis, and if we're going negative, we go this way. Since this is in radians, I'm gonna change that into degrees because I think it's a little easier to work with degrees rather than radians. So I'm going to take the negative 7 pi over 3 and times it by 180 over pi. That changes it to degrees. The pi's cancel. I'm going to do some cross simplification here. That's going to go to 1. Dividing that by 3 takes that to 60. So now all I have to do is 60 times negative 7, which is negative 420 degrees. So we're going to go negative 420 around clockwise. This is negative 90. This is negative 180, negative 270, negative 360. So right now we went here, here, and back around again. Another 90 makes this negative 450, but that's a little too far. So we have to go, let me show you how we're going again. We're going around and then back a little bit more. So we had to go 60 degrees more, which is like right here. There's our terminal side. There's our initial side, and it's in quadrant 4. Write down any questions you have about 1 and 2. Let's go to 3 and 4 for this video. 3 and 4, we have to find the measure of the angle. We have to find this part right here. We're given that 140 is from here to here, but we know a straight line is 180 degrees. So 180 minus the 140 gives us a leftover of 40 degrees right there. Number 4 is in radians, so our answer has to be in radians as well. We're given that this little piece right here is pi over 4, but we want to find the remaining all around piece. We know a whole circle is 2 pi in radians, but we already are given pi over 4, so we're going to subtract these two. Making common denominators when we subtract. I'm going to change that to 4. That's going to be 8. So we're going to be left with 7 pi over 4. That's the remaining large piece around. Before we go to 5 and 6, I do want to talk about number 3 again. Number 3, I did have a little mistake here. Since this angle is going backwards, this 40 degrees has to be negative. So the answer number 3 is negative 40 degrees. Number 4 is still positive since we're going around in the positive direction, so it's positive 7 pi over 4. Let's move on to number 5. Finding the reference angle. The reference angle, a lot of you forget, is the measure from the terminal side to the x-axis. So I'm going to shade in what we need to know. That's the reference angle, how much that is. We're given that a full angle here is 230 degrees. But a way to figure this out is that we know that this is 180. So how much left over to get to the full 230 is 50 degrees. And that's it. Just how much this little part of the angle is. Let's do number 6. I'm going to shade in what we need to know. The reference angle is right here. Again, it's between the x-axis and the terminal side of the angle. We're given that going backwards, that is negative 3 pi over 4. But a full half of the circle is pi, or going backwards in this case is negative pi. So how much more this little piece has to be to make a full negative pi? So if we have negative 3 over 4, this remaining piece has to be just 1 pi over 4. And reference angles are always positive. So even though this angle is negative, your reference angle is always going to be positive. Again, we found pi over 4 because it was the leftover, this little piece right here, what I shaded in. Given that 3 pi over 4 was this much, how much more do we have to make a full pi? Because pi is at 180 degrees here. Again, if you don't like the radians, you can switch it to degrees and then find your answer and then switch your final answer back to radians. Let's move on to number 7. Finding the area of each triangle to the nearest tenth. Normal triangle area formula is 1/2 base times the height. But these triangles don't really have normal heights. They're oblique triangles, they're not right triangles. So we have to use a specific formula, and that formula is 1/2 AB sine C. Lowercase letters stand for sides, uppercase letters stand for angles. We need to make sure that we have everything first in the triangle before we plug it into the formula. Since we do not know everything we need for this area formula, for example, we don't know A, but we do know B, and we do know the angle C. Let's find A real quick. And to do that, we're going to use the law of sine to find A. And the law of sine is sine A over A equals sine, and I can pick, let's do B, sine B over lowercase b. And we do know angle B in this case because we can do 180 minus 38 minus 75, and we'll get 67 to be B. Now plugging these into the law of sine formula, we get sine 75 over A, which we're trying to find for this formula, equals sine 67 over B. B in this case is 5.8. We're going to cross multiply and solve. So we have sine 75 times 5.8 is going to equal A times sine of 67. And then we're going to divide over the sine 67. It's going to do that here instead of writing out another step. In your calculator, make sure you are in degree mode and see what you come up with. I got A to equal 6.09 inches. Now we have everything we need for our area formula. I'm going to plug everything in. So we get A is 6.09, side B is 5.8, and then we have sine of the angle C, which is 38 degrees. Plugging those in, we get the area to be, write it over here, 10 point, and since we're rounding to the 10th, going to be 10.9 inches squared. Again, that was a little tougher because we had to use law of sine prior to using the area formula. We're going to have to do the same type of stuff with number 8, I believe, as well. So let's erase this and then get to number 8. Rewrite the area formula. And then I have C. So I know that the angle C is 21. And here's A and here's B. So I know B. B is 15. But we don't know A. So we're going to have to use law of sine again. And remember, we know to use law of sine when we are given the same letter, lowercase and uppercase. In this example, we are given both b's, so we're given lowercase b and uppercase b. And we're not necessarily given it, but we can find easily uppercase b by doing 180 minus 21 minus 36 to make 123. And I think law of sine, when you can use it, is a lot easier than law of cosine. So let's find A by doing a law of sine. Sine A over A equals sine, and we're using B to relate it with. Sine A is sine 36 divided by little a, which we don't know, but we know sine of big B, and we know little b is 15. Cross multiplying to solve, we get A times sine of 123 equals 15 times sine 36, and then dividing both sides by sine 123, it comes out to look like this. Plugging this in your calculator, you get side A to 10.513. Now we can plug that back in into our area formula, into there. So the area is going to equal 1/2 times 10.513 times side B times the sine of 21, because that was C in this case. Plug those in, see what we get. We get the area to equal 28 points, since we're rounding to the 10th, 3, and this is in feet squared. And there we go. Tough problem, but we did it. I'm going to have the next few problems on the next video.